Hello guys, welcome to Java Developer Real-Time Interview Questions Part 2. What is difference between iterator and splitterator? Iterator is used to traverse the collection in a sequential manner, but splitterator is used to traverse the collection plus divide it into multiple parts and it can run parallel. Let's see the differences. Iterator is introduced in Java 1.2 and splitterator is recently came in Java 8 features. And iterator can traverse elements in sequential, and splitterator can traverse element in sequential plus it can do parallel processing of the elements present in the collection. Here the methods of iterator is iterator has methods like has next, next and remove. Has next will return a boolean whether the element is present or not, or next element will give you the next element, and remove will remove from the collection. Here these methods in splitterator are try split. Try split will return the split one more splitterator by splitting it into multiple parts. And try advance. Try advance will pick the element whether if it is present in the collection and it will process the element. For each remaining will get all the remaining elements from the collection and it will traverse all the elements. And estimate size will give you the size of the collection or size of the splitted collection. And here we cannot use iterator with stream API, but we can use splitterator with stream API. We can stream the elements. And real-time use cases for iterator are if we want to show any list of products or customer reviews, basically which consist of traversal, we can use this iterator. For real-time examples for this splitterator are if we want to process orders in parallel with a different status. For example, if we want to process order with submitted one way and order with received as one way. For this purpose we can use a splitterator. For search and filters options also we can use this splitterator. We can split and perform these search and filter operations. Next question is difference between hash map and concurrent hash map. Here hash map is works fine for single threaded environment, but when multiple threads access the hash map and try to modify, then it will throw the exception, concurrent modification exception. To resolve this issue, concurrent hash map came into picture, and concurrent hash map can work with multiple threads by providing segment locks. We can use thread safe T for hash map as well by using synchronized, but it will lock the entire map and no other thread can access the map. Let's see the differences. Hash map is suitable for single threaded environment, and it is a fail fast iterator where it will throw the concurrent modification exception if multiple threads try to update or delete anything from the hash map while iterating. And it allows the null key and values. And if we use synchronization for this hash map, it will lock the entire map and no other thread can access this hash map. It will provide you the poor performance. That's why concurrent hash map came into picture. This is introduced and it is suitable for multi-threaded environment where multiple threads can access this concurrent hash map. And it is a fail-safe iterator because it performs the update, delete, and add option operations on a snapshot of the map. Basically, it will create a snapshot of the existing hash map and it will perform operations on that copy map. That's why this original map will not get affected, and it does not allow any null keys or values because it performs with multiple threads, and it will provide the segment locking mechanism where each index is divided into segments, and it will provide a lock only for that particular index if it is doing any operations like update or delete. It will lock only that part and it will update the element, and it will provide the read options for multiple threads. This way concurrent hash map works. And the next question is difference between runnable and callable. Here runnable and callable both are for using threads, where runnable cannot return the value and callable can return a value. For example, if you want to process a thread and you want to return any result from that thread after execution, then runnable won't work for that. For this, to solve this problem, callable is introduced. Callable can return the value after execution of the thread, and runnable does not have any value and it cannot throw any checked exceptions. These are the limitations of runnable. It consists of a void run method. That means it cannot return any value, and it can be used with thread or executor service. Both we can use. And real-time scenarios for this runnable is when you don't need any return value after execution of thread, or you don't need to handle any exceptions while using the thread, then you can go with runnable. And for example, for this are sending email. If you write one service which sends email and it does not require any return value, or you want to update any inventory that doesn't require any return value, so in this case you can go with runnable. And this is the syntax of runnable, where we can create runnable my runnable equals to this lambda function. And to resolve all these issues, callable came into picture. Callable can return a value, and it can throw the some of the checked exceptions. And here the method of callable is call with return type as a t. And we can use this with executor service. We can also use it with the thread, but it will perform the same operation, but thread cannot get any return value. So by using executor service we can get value in return. By using future we can get that value. And real-time use cases for this callable is if you want to return any value, like for example you want to calculate the total price of the product and you want to return the total price, then you can use this callable functionality for getting the value. Or for example you want to validate whether the order is valid or not. In this case also you can return boolean value by using this callable. And this is the syntax of callable method, sorry, callable, where my callable equals to lambda function and it can return the result. And this is one of the important questions from Spring Boot. What is Spring Boot actuator and how do you configure it, and how would you provide the security, because it is a management endpoint, so we need security for actuators. Here basically Spring Boot Actuator is a powerful feature where it provides the health metrics and configurations of our application. Then some of the endpoints are like this. We can use actuator slash health, actuator slash metrics, actuator slash env to get environments, or slash config props to get the configuration properties, slash thread dump to get the thread dump details. By using these endpoints, we can get our application matrices. And coming to configuration, we need a dependency to add it to our build.gradle or pom.xml. If you are using Maven, then you need to add Maven dependency. For simplicity, I added this Gradle dependency, Spring Boot starter actuator. This is the dependency we need to add in our pom.xml or Gradle file. After that, in application.properties, you need to expose these endpoints by using this management.endpoint.web.exposure.include. Whatever the things we need to include, we have to mention here, like health info metrics or config props or thread dump. This way we can use this. And to provide security for these endpoints, then we can do it at HTTP security level, where WebMVC configure adapter is set up in security config. Within that setup, we can add these ant matchers, like if we use slash actuator, then we can assign a role to it. Here I assign admin role, where only admins can use these actuator endpoints. If you want to assign it to some other role, like actuator underscore admin, who wants to access for that actuator endpoints, you can provide that permissions to this role, so they can access this actuator. Next question is how @transactional internally works within the Spring Boot. Here @transactional work on proxy based transaction management, where it will create a proxy bean for that particular service, and it will intercept the requests, and based on the transactional management, like whether we need to commit or do rollback, these all can be done within the proxy bean. Like here transaction proxy factory bean will be created around that service where you mentioned this @transactional. This annotation you can add at method level, or you can add it directly at class level based on the requirements. @transactional factory bin, this is responsible for handling all the transaction related logic, whether it uh, to define all the asset properties, whether it is working or not, based on the results. All this will be present within this proxy factory bin. And this is the transactional manager, where it is responsible for the transaction, like it is uh, whether the transaction needs to be commit or rollback. The transaction manager plays a crucial role here, and it manages the actual transaction based on the transactional conditions, whether we need to create a new connection for this, or we can we continue with existing connection, or if we want to, this way transaction manager provides the, like for example, if a transaction need to be committed or rollback, that will be decided by this transaction manager based on the results. This method execution part, where it sends the results of the query, like whether the query got successful, or is there any errors present in the query. It send results back to the transaction manager. So this transaction manager decides whether it needs to be committed or it needs to be rollback. This way, this transactions works internally using the proxy bean and transaction manager. And here there is an important note, uh, calling a method annotated with @transactional from using the same class. It will not trigger the transactional management provided by Spring because transaction management is applied through proxy created by Spring, and a proxy mechanism does not apply to method calls within the same class instance. Simply, if you annotate with @transactional within the service and you called it within the same service, then this transactional properties will not work because it will create bean for the entire service. That's why within the same service it won't work. Coming to next question, how do you maintain communications between microservices? Here we can maintain communication in three different ways. Like we can go with the REST template where you already using REST template in your old applications. Then you can continue using this REST template. Here it can be used in traditional or synchronous applications where blocking is acceptable. For example, if you use REST template until the results are getting back, the it is blocked in in the execution. So another another type of communication is using Fin client, where if you are using Spring Cloud environment, you can go with Fin client, and Fin client basically creates an interface and whatever the methods required from the other service, we can define those methods and their return types in the Fin client. By using those, you can directly use this declarative manner of getting data from other service. And third one is web client. Web client is for asynchronous communication. Like for example, if you are using Spring Reactive, then you can go with web client where this can provide asynchronous way of non-blocking communication, and it will not block any execution in between. Whenever the execution is completed, it will do the callbacks and send data to the application. Web client is used for Spring Reactive applications, and there is one more way, which is event based communication. For example, if there is any event happened in one service, and based on that event another service should work. For example, if order submission is done, then it should redirect to the payment. This type of for asynchronous or event based communications, we can use messaging brokers like RabbitMQ or Kafka. For event based communications, we can use this Kafka or RabbitMQ. Coming to next question, JPA repository is an interface, but when you use the @ annotation for the repository interface, how the object is getting created and how this default find by ID, find by username, these methods are working. Here JPA repository is automatically created bins by using Spring Data JPA at runtime. And here Spring uses a mechanism called proxy creation to provide the implementation. When you use @autoword on the repository interface, Spring inject a proxy instance that implements the interface. Basically, Spring creates a proxy bean for those things at runtime. And while during this component scanning of application startup, Spring detects all these interfaces which are annotated with @repository and extends with the JPA repository. These beans are already registered with in the Spring context, and when you use @autoword, then those are automatically injected using this Spring Data JPA. And in Spring application, auto configuration helps to set up these JPA related configurations automatically. And Spring Data JPA uses Entity Manager for interacting with the database. And thank you for watching. If you need any more information, then please do comment. I will work on those topics. Thank you.